Good morning, my dear friends. In the last class, we have seen how to solve the problem on stress analysis and strength concept, stress concept, strength concept, and load balancing concept. Okay. Now we shall further move on to the next important this thing. Now it is analysis of sections for flexure. Okay. See now here now in this chapter we are going to solve some of the problems purely by using stress concept, purely by using your stress concept. So now you know that the stress concept says now you need not worry or you need not remember all the equations what we have studied in either say strength concept or in your load balance concept, etc. Okay, now I request you to remember only one equation, okay, by using your stress concept what we have studied. It is F is equal to F by A plus or minus Fey by I plus or minus My by I. Otherwise, My by I can be split up into Mdy by I plus or minus Mly by I. Am I right now? Where M is equal to now Md plus Ml. Okay. So now this is the equation which we are going to use now throughout in our precious concrete this thing now. Analysis. Okay, so now this equation you will have to now remember. So now before I start with this problem in this chapter, I would like to cover a small thing, okay, which we call it as the loss of pre-stress. So what exactly this loss of pre-stress is? Okay, see now see now here what happens is now this the equation whatever you have seen just now, okay, in sense F is equal to F by A plus or minus Fey by I plus or minus My by I. But now here this pre-stressing force F whatever we have here in this and here, but now this pre-stressing force, okay, may be of initial pre-stress or the final pre-stress. So now what exactly the initial pre-stress is and the final pre-stress is? Let us try to see now. But now initial pre-stress means whenever I apply the pre-stress to the beam, whenever I transfer the pre-stress to the beam, okay, so that initial value of the pre-stress I will call it as initial pre-stressing force. Okay, now what happens is after some days or after some years you will see that this initial pre-stressing force, say take for example now here I applied a pre-stressing force of say now 1000 kilonewton. Say assume that I have applied a pre-stressing force of 1000 kilonewton. But now this 1000 kilonewton pre-stress will not remain constant throughout the life of the structure. No, it won't remain. It won't remain constant. 1000 kilonewton pre-stress, it will come daily. In sense now there will be some loss of pre-stress. There will be some loss of pre-stress, and after some years it will attain a certain value, and that value of pre-stress I will call it as effective pre-stress, or it's also called in a sense now, okay, it's called effective pre-stress or it's also called final pre-stress. Okay, it's called either effective pre-stress or it's called final pre-stress. So now I've got two things now here. Now please try to understand. Okay, this value of F, it may be initial pre-stress, okay, or it may be a final pre-stress. Okay, final pre-stress is obtained after the loss of pre-stress. Okay, say take for example now 1000 kilonewton pre-stress whatever you have applied here as initial pre-stress. After 1 year it may come down to 970 kilonewton. Okay, it may come down to 970 kilonewton. So this 970 kilonewton I will call it as effective pre-stress, and initial pre-stress is 1000 kilonewton. Am I right, sir? No? So there is certain loss of pre-stress as I have said you. So now here we are going to define one important term called loss factor. Okay, we are going to define here something called loss factor eta. Okay, so this loss factor eta can be defined as it is the ratio of effective or final pre-stress divided by initial pre-stress. Initial pre-stress is called F. Okay. So now effective pre-stress divided by initial pre-stress, this ratio I will call it as the loss factor. Okay. Otherwise, from this equation, if at all I want effective pre-stress or the final pre-stress, effective pre-stress or final pre-stress is equal to, it is eta times F. Am I right? Now eta into F will give me the effective pre-stress or the final pre-stress. Okay. So now usually what happens is, now this loss factor eta, okay, it is always less than 1. It is always less than 1. Okay. And usually eta varies from 0.7 to 0.85. In the sense, I say that, okay, around in sense, now the loss of pre-stress varies from, oh sir, now anything from 30% to 0 to 30%. Anything from 0 to 30% will be the loss. That's why this loss factor eta, okay, it varies from 0.7 to 0.85. 0.7 means 30% loss has taken place. Am I right now? If eta is 0.85, I say that 15% loss has taken place. Is it or not now? So now this is how you can calculate the loss of pre-stress, and we can define this loss factor eta. Okay, it is effective pre-stress divided by the initial pre-stress, or if you want effective or final pre-stress, it is eta times initial pre-stress. Okay, so now based upon this, okay, now we'll try to solve some of the problems, how to analyze the PSC beams or slabs. Okay sir, now thank you very much. We'll stop it now.